Um, Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Electrochemistry. So any doubts if you have in any steps, then please write that in the comments section so that we shall clarify them in the subsequent videos. Also, in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that an aqueous solution of CuS4 is subjected to electrolysis under using inert electrodes. So an aqueous solution, here we take an aqueous solution of copper sulfate and it is subjected to electrolysis and using inert electrodes. So one cathode and anode is used. Then the pH of the solution will. So what will happen at the anode? As we know that at the anode oxidation will take place. Now it means that H2O will be oxidized to oxygen, means 2H plus ions plus 2 electrons plus half O2. So here H plus ions will be formed and oxygen gas will be li- liberated by the loss of two electrons. Then at the cathode, re reduction will take place. As we know that at cathode reduction takes place and at anode oxidation takes place. So at the cathode, the uh, copper atoms is the uh, copper ions from copper sulfate. We will get Cu2 plus ions and sulfate ions. Now the copper ions will gain 2 electrons to form copper atoms. So copper will be deposited at the cathode and oxygen will be obtained at the anode. Now therefore the overall cell reaction is simply we will add these two and we will cancel out the two electrons. So therefore we will get H2O plus Cu2 plus, that gives 2H plus Cu plus half O2. So here it means that in the solution, the concentration of the H plus ions will increase. Now the pH, as you know, that is equal to minus log of concentration of H plus ion. So it means that if the concentration of H plus increases, the pH value will decrease. So here it means the pH value of the solution will decrease. So option C is the correct answer. Then here it is told, given that E naught Mn7 plus to Mn2 plus is equals to 1.5 volt and E naught, it, it means here it is given the re reduction potential for Mn7 plus to Mn2 plus and E naught from Mn4 plus to Mn2 plus, that is given as 1.2 volt. Now therefore the value of the E naught Mn7 plus to Mn4 plus, that is how much? That is being asked. So now as we know that um, delta G naught, that is equals to minus NF E naught cell. So here in the first reaction, Mn7 plus ion will gain 5 electrons to form Mn2 plus ion, and here the E naught value is, let's call it as E naught 1, so that is 1.5 volt. Now therefore delta G naught 1, that will be is the Gibbs free energy change for the first reaction. So that is minus NF E naught minus NF. So that is minus NF E naught 1. So that will be, now here 5 electrons are involved. So N will be 5. So it is minus 5F into E naught 1. Similarly, in the second reaction, Mn4 plus will gain 2 electrons to form Mn2 plus N. And here the E naught 2 that is given as 1.2 volts. Now therefore delta G naught 2 that will be equal to minus NF E naught cell. So here N is 2, since 2 electrons are being gained here by Mn4 plus. So it is minus NF into E naught 2. Similarly, Mn7 plus should gain 3 electrons to form Mn4 plus. So now here we see that if we subtract the second reaction from the first reaction, from this first reaction means we do first minus 2, then we will get this third reaction equals to the third reaction. So therefore we can say that delta G naught 1 minus delta G naught 2 that will be equal to delta G naught 3. Here the delta G naught 3 that is equals to minus 3F into E naught 3. Now this E naught 3 only has been asked, which you have to find out. E naught 3, which is E naught Mn7 plus to Mn4 plus. So therefore delta G naught 1 that is minus 5F E1, sorry, minus 5F E naught 1 minus this is minus of 2F E naught 2, that is equals to minus 3F E naught 3. So here F will get cancelled. So therefore we can say that this is 2 E naught 2 minus 5 E naught 1, that is equals to minus 3 E naught 3. So therefore E naught 3 that is equals to 1 by 3 times 5 E naught 1 minus 2 E naught 2. So that will be equal to 1 by 3 into 5 E1. 5 E1 is 5 into 1.5 volt minus 2 into 1.2 volt. So this will be 15 5 is 75. So 7.5 minus 12 to the 24, so 2.4. So that is 5.1. So half of 1 by 3 of 5.1, that is equals to volts. So it is 3 1 is 3, 3 7 is 21. So 1.7 volt. It will be 1.7 volts. So option C is the will be 1.7 volts. So option C is the correct answer. And here it is told a pair of electrolyte that possess same value for the constant A in the Debye-Huckel-Onsager equation is. So the rule is that in the Debye-Huckel in the Debye-Huckel-Onsager equation, the value of the constant A, it depends on the nature of the electrolytes. It depends on the nature of the electrolytes. It means that it depends on the charge of the anion and the cations. It depends on the charges of the anions and the cations produced by the dissociation of produced by the dissociation of electrolytes in the solution. Now NH4Cl on dissociation, it will give NH4 plus ion and Cl minus ion respectively. And then NaBr, that will give Na plus ion and Br minus ion. So they have the same charges. But in the option B here, Br will give Na plus and Br minus, but MgSO4 will give Mg2 plus and SO4 2 minus. So the charge is not same. So it means the value of the constant A will not be the same for both these electrolytes. So only for the option A, the charges are same for the anion and of the cation. So here the value of the constant A will be also the same. Option A is the correct answer. Yeah. Then here it is told that given E naught Fe3 plus to Fe2 plus, that is equals to plus 0.76 volt, and E naught I2 to I minus, that is equals to plus 0.55 volts, and the equilibrium, then the equilibrium constant of the reaction taking place in the galvanic cell consisting of the two above electrodes is. So now, as you know that E naught cell, that is equals to minus RT minus 2.303 RT ln K by NF. So now 2.303 RT by F is 0.06, so it is be minus 0.06 by, now here N will be equal to 2 here, since here 2 electrons will be involved, into ln, no sorry, into log K, to log Kc, where this equilibrium constant Kc only we have to find out. Sorry, it is 2.003 RT by NF ln Kc. So this minus sign will not come here. Minus sign will not come. Now here in the cell reaction is that Fe3 plus will go to Fe2 plus, so it will react with I2 to give Fe2 plus plus I minus 2 I minus. So now here I2 will gain two electrons. Here it will gain 2 electrons, and Fe2 plus it should also gain, it should also lose, no, it should gain 2 yeah, and here it means that I minus will go to I2. Okay, sorry. I minus will go to I2. So 2 I minus will go to I2. It will be 2 Fe2 plus. So here this will lose 2 electrons, and here there is oxidation, and this one it will gain 2 electrons. So it means here 2 electrons are involved. So the N value is 2 here. Now here, so it is the overall cell reaction which is happening here. So now therefore the E naught cell, therefore now the E naught cell, that is equals to E naught at the cathode, means the re reduction potential at the cathode, which is Fe3 plus to Fe2 plus, minus the reduction potential at the anode, means E naught from I2 to I minus. So this will be equal to 0.76 volt minus 0.55 volt. So this is 0.21 volt plus 0.21 volt. So now Kc you have to find. So now therefore now this 0.21, that is equal to 0.06 by 2 into log Kc. This is 0.03. So log Kc, that will be equal to 0.21 divided by 0.03. So this will be 3 sevens are 21. So Kc will be equal to 10 power 7. So 10 power 7, it means 1 into 10 power 7. So option D is the correct answer. Then here it is told, if an aqueous solution of sodium fluoride is electrolyzed between two inert electrodes, the product obtained at anode is. So the rule is that when an aqueous solution of sodium fluoride is electrolyzed between inert electrodes, then at the cathode, at the cathode, hydrogen gas is obtained. Hydrogen gas is obtained. It means the reaction which happens at the cathode is 2H plus, that gains 2 electrons to form hydrogen gas, and at the anode, um, oxygen gas is obtained. Oxygen gas is obtained. Here it means that at the anode, 4 hydroxide ions that will lose 4 electrons. So it will form 2H2O plus O2 plus 4 electrons. So here there is oxidation. Oxidation is happening, so O2 is obtained. So the product obtained at anode is O2. So option C is the correct answer. Then it is told, consider the following electrodes P, Q, R, and S, where E0, Zn2, Zn2 plus. So here it is told the oxidation potential, the oxidation potential of zinc Zn2, Zn2 plus, that is minus 0.76 volt. The electrode potentials of the above electrode in volts are in the order. So now, as you know that the potential electrode potential at any temperature, that is E naught or E cell, that is given as E naught cell minus 2.303 RT by NF log QC, log Q, log Q. Q means here it should be here, zinc is being reduced to zinc. So here Q will be equal to 1 by concentration of the zinc. Q is the reaction quotient. So that will be 1 by zinc concentration. Or therefore E cell, we can say, it means that E the electrode potential of zinc Zn2 Zn2 plus, that will be equal to E naught Zn2 Zn2 plus, then plus we can write 2.303 RT by NF log Zn2 plus, concentration of Zn2 plus. So therefore now this we have to find out. Now therefore this we can also write E Zn2 Zn2 plus, that is equals to, this is minus 0, okay, here actually oxidation is happening, Zn is moving to Zn2 plus, so it will be Zn gives Zn2 plus 2 electron. So it is the oxidation potential, oxidation potential which is happening at the anode. So here the reduction potential has been asked, we have to find out. So this will be equal to actually E naught cell, then this should be Zn2 plus. Okay. So Zn2 plus is 0.76, but here Zn2 plus is changing to Zn. So yeah, this should be, so this one is the cell reaction which is happening, and it should happen at the cathode since reduction is happening. Zinc Zn2 plus is reduced to zinc. So this should be from Zn2 plus to Zn, Zn2 plus to Zn, Zn2 plus to Zn. This one we have to find out the order for this. Now, since E naught Zn2 Zn2 plus is minus 0.76 volts, so E naught Zn2 plus 2 Zn. Since why this one is the oxidation potential, and here since reduction is happening at the cathode, so we need to use the reduction potential. Now reduction potential is equal to the negative of the oxidation potential, means it is minus of minus 0.76, so it is plus 0. That is, yeah, plus 0.76 volt. So this will come 0.76 plus this will be 0.5059 divided by n. N here 2 electrons are involved, so 2 into log of concentration of Zn2 plus. So simply it means that here the reduction potential of the zinc, that is that will increase if the concentration of the zinc ion, the concentration of Zn2 plus increases. So therefore we can see that as the concentration of Zn2 plus increases, the reduction, the standard reduction potential of zinc from zinc 2 plus to Zn, that will also increase. So here the concentration is the highest for Q. So for Q, the electrode potential will be the highest. So for Q it is the highest, and for Q it is the highest, and the least is for l- least is for the least concentration of zinc 2 plus ion, which is P. So P is the least, and slightly less than Q is R. So QRSP, QRSP. So option C is the correct answer. So option C, that Q more than R more than S more than P is the required order of the standard electrode potentials or simply the electrode potentials for P, Q, R, and S. Okay. Mm, so here it is told that the resistance of 0.01 molar KCl solution at 298 Kelvin is 1500 ohm. If the conductivity of 0.01 uh, molar KCl solution at 298 Kelvin is 0.1466 into 10 power minus 3 Siemens per centimeter, the cell constant of the conductivity cell is. So now the cell constant, therefore the cell constant that is given as cell constant, which is G is given as the specific conductivity into the resistance. So therefore the specific conductivity is given as 0.1466 into 10 power minus 3 Siemens per centimeter. Siemens means ohm inverse centimeter, ohm inverse per centimeter, and into the resistance, which is 1500 ohm. So it means it will be 1.5 into 0.1466 ohm, and per ohm will cancel. So this will be per centimeter. So this will be equal to, this will be approximately equal to 0.219 per centimeter. So option A is the correct answer. Then it is told E naught cell at 25 degree Celsius for the cell is 0.22 volts. The equilibrium constant at 25 degrees Celsius is. So now the E naught cell that is given as 0.22 volts. The equilibrium constant at 25 degrees Celsius is, the equilibrium constant okay, equilibrium constant Kc has been asked at 25 degree Celsius. So now E naught cell that is given as 2.303 RT log Kc by NF. Now here H2 plus 2 HgCl gives 2 Ag plus HCl, 2 HCl. So here Ag plus is so the silver is converting into +1 oxidation state to 0 oxidation state. So here it should gain 2 electrons. Here also it should lose 2 electrons. So here 2 electrons are involved. So it means that N equals to 2. And at 25 degrees Celsius, the value of 2.303 RT by F, that is equals to 0.059. So therefore E naught cell, that is 0.22, that is equals to 0.059 by N, that is 2, into log Kc. So therefore log Kc, that is equals to 0.44 divided by 0.059. So which is approximately equal to, so which is approximately equal to 7.46. So therefore Kc will be equal to 10 power 7.46 or 7.5 you can tell. So root over 10 is approximately uh, root over 10 is approximately 3 point something. So 10.46, so 7.46. So 10 power 0.46 into I can do 10 power 7. So 10 power 0.46 is approximately 2.8. 2.8 into 10 power 7. So it means that the value of the equilibrium constant is 2.8 into 10 power 7. So option A is the correct answer. Then it is told the specific conductance means K, the value of K, the specific conductance is 6.3 into 10 power minus 2 per ohm per cent centimeter, and concentration the concentration or the molarity of the nitric acid solution is given as 0.1 molar. So the molar conductance of the solution is now, therefore the molar conductivity lambda m, that is equals to the specific conductance into 1000 divided by m, which is the molarity. So this will be equal to 6.3 into 10 power minus 2 into 10 power 3 divided by m, which is 0.1, so 10 power minus 1. So this will be 6.3 into 10 power mm, 4 minus 2, that is 2. So 6.3 into 10 power 2 per ohm, and molar, it means I can tell it is, so here the molar concentration, okay, so it will be per ohm centimeter square per mole. Molar, it means that it is mole per liter, or I can say mole per liter. Now 1 liter is 1000 centimeter cube. So it means therefore I can write the molarity will be equal to 0.1 into 1000, 0.1 into 1000 mole per centimeter cube. 1 liter means 1000 centimeter cube. So sorry, this by 1000 mole per centimeter cube. The molarity, if it is 0.1 mole per liter, that we can say it is 0.1 by 1000 mole per centimeter cube. So it means that lambda m, that is actually equal to K by m only, but this, where m is the molarity, and if we take the molar concentration in mole per centimeter cube, then we have to multiply this by 1000 in the numerator. In the numerator we should multiply it by 1000. So therefore it will be 630 per ohm per ohm centimeter square per mole. So option C is the correct answer. For spontaneity of a cell, which is correct? Now, so for spontaneity, the change in Gibbs free energy delta G should be negative. Delta G should be negative, and we know that E naught E cell is equals to uh, minus delta G by NF. So it means that the EMF of the cell should be having the opposite sign of delta G. So E cell should be positive. Then only the cell reaction will be a spontaneous reaction. Then only the cell reaction is spontaneous. Then only the cell reaction is spontaneous. So delta G should be negative. So option B is the correct answer. In fuel cells, dash are used as catalysts. So in fuel cells, the platinum palladium catalyst is used um, in the f- i- in the reaction in fuel cells. Since in fuel cells, the reaction which happens is that um, hydrogen and oxygen forms H2O. So here it increases the rate of the electrode reactions. It increases the rate of the reaction. So if platinum and palladium catalyst is used, it increases the rate of the reaction, increases the rate of the reactions which happens at the electrodes. It means at the anode and at the cathode. So option C is the correct answer. The molar conductivity is maximum for the solution of concentration. Now, the molar conductivity, as you know, molar conductivity is given as the specific conductance into 1000 by the molar concentration. So it means that the molar conductivity is inversely proportional to the molar concentration of the solution. So it means that if the concentration of the solution decreases, then the molar conductivity increases. So here the least concentration will have the maximum molar conductivity. So here the least concentration is 0.001 mo molar. 0.01001 molar is the least concentration here. So it will have the maximum molar conductivity. So option B is the correct answer. Then here it is told during the electrolysis of brine by using inert electrodes, what uh, what is liberated at the anode and what is liberated at the cathode. We have to know that. So brine solution, during the electrolysis of brine solution, now brine solution, it means that it is the aqueous solution of sodium chloride, NaCl. So now um, here Cl2 gas is liberated, since why Cl minus 2Cl minus will lose 2 electrons and it will form Cl2 gas. So here oxidation is happening at the anode. Oxidation happens at the anode. So at anode Cl2 gas is liberated at the anode, and at the cathode H plus ions, two H plus ions will gain 2 electrons to form H2. So H2 gas is liberated at the cathode. So option B is the correct answer. Then here it is told, consider the following 4 electrodes, then reduction uh, potential in volts of the electrodes are in the order. So now here, as you know that the reduction potential of silver, so here silver Ag plus will gain 1 electron to form Ag. So it is a reduction half reaction. It is the reduction half reaction which will happen at the cathode. So here the reduction potential, which is E Ag plus 2 Ag, that is equals to E naught Ag plus 2 Ag minus 0.059 by N. So here N will be 1 only, since here one electron is involved. 0.059 by M log of the 1 by concentration of Ag plus, which is the QC. QC is the reaction quotient, or therefore we can say it is, which is 0.8. Value of this is given as 0.8. So 0.8 plus I can write 0.059 log of concentration of Ag plus. So therefore the reduction potential, which is equal to 0.8 plus 0.059 log of concentration of Ag plus. So it means that if the concentration of Ag plus increases, then the reduction potential will also increase. So therefore the least concentration of silver will have the least reduction potential also. So here we have to arrange in the descending order. So therefore the highest concentration of silver is in the option B only. So B is more than C, which is more than D, which is more than A. So B, C, D, A. So option C is the correct answer. Then here it is told the resistance of a 0.1 molar weak acid HA in a conductivity cell is 2 into 10 power 3 ohms. So the resistance value is given 2 into 10 power 3 ohm. The cell constant of the cell constant, which is G is equal to the specific conductance K into R, that is given as 0.78 coulomb per meter. And then the lambda m naught, which is the molar conductivity of the acid HA, that is given as 390 Siemens centimeter square per mole, which is so now Siemens is per ohm. It is 390 per ohm centimeter square per mole. So now the pH of the solution has been asked. pH will be how much? Now so from here pH is equal to the minus of log of concentration of H plus, obviously, and here so the weak acid HA will hydrolyze as um, HA will hydrolyze in the form H plus plus A minus. So now so here the first, so here if the initial concentration was C, then C alpha will be So if alpha is the degree of uh, dissociation of the acid, degree of dissociation of the weak acid, so C minus C alpha, so C alpha will be the concentration which will react, and C alpha will be the amount of H plus which is formed, and C alpha is the amount of A minus ion which is formed. So therefore the H plus concentration will be equal to C alpha, where C is the concentration of the weak acid, which is 0.1 molar, which has been told here, and therefore now lambda m naught, that is given this, and then alpha is the degree of dissociation of the weak acid, that is equals to lambda m by lambda m naught. Now lambda m, how to find? As you know that lambda m, that is given as k into 1000 divided by m. Now the specific conductance k, so the specific conductance k, that will be equal to g by r. G by r, g is 0.78, so it will be g 0.78 into 1000 divided by r. R is 2 into 10 power 3 into the molarity of the solution, that is 0.1. So this will 10 power 3, 10 power 3 will cancel out. So this is 0.2. So this is 0.78 by 0.20. So 2 ones are 2 tens are 20, and 2 twos are 2 fours are 2 3 are 6, 2 nines 18. So it is 3.9 Siemens centimeter square per mole. So now therefore the degree of dissociation alpha, that is equals to lambda m by lambda m naught. Now lambda m is given as 3.9 Siemens centimeter square per mole, and lambda m naught is given also as 390 Siemens centimeter square per mole. So therefore 3.9 by 390, so that will be equal to 0.1 by 10, so that is 0.01. Now therefore the concentration of H plus is equal to C alpha. So C is given as 0.1, 0.1 into 0.01. So that is 10 power minus 3. So therefore the pH of the solution is minus of log of H plus concentration. So that will be equal to minus of log of 10 power minus 3. So that will be equal to 3. So pH equals to 3. So option B is the correct answer. Then here it is told aluminum displaces hydrogen from dilute HCl, whereas silver does not. Aluminium displaces hydrogen from dilute HCl, whereas silver does not. The EMF of a cell prepared by combining Al to Al3 plus and silver to silver Ag to Ag plus is 2.46 volts. The reduction potential of silver electrode is the reduction potential of silver electrode is 0.8 volts. The reduction potential of aluminum electrode is. So now therefore um, the E cell is given as 2.46 volt, and that is equal to the reduction potential of silver electrode. Aluminium displaces hydrogen, but silver does not. So it means that aluminium will easily form Al3 plus. This will be positive, and silver can A- Ag plus will form Ag. This will be positive. So it means this will happen at the cathode, means Ag plus will convert to Ag at the cathode and aluminum will change into Al3 plus at the anode. So it means that we can say E cell will be equal to the reduction potential of silver electrode Ag plus to Ag minus the reduction uh, potential of the aluminum electrode Al3 plus to Al. So the reduction potential of silver electrode is 0.8. So therefore 2.46 equals to 0.8 minus Al3 plus to Al. So therefore Al3 plus to Al, that will be equal to 0.8 minus 2.46. So that will be equal to, so that will be equal to m- minus 2.46 minus 0.8. So that will be equal to 661. So it is minus 1.66 volt. So option 2 is the correct answer. Then here it is told that if the electrolytic method of obtaining aluminum from purified bauxite, cryolite is added to the charge in order to, the reason is to dissolve bauxite to and to render it conductor of electricity. So it means that in the electrolytic m- method of obtaining aluminum from bauxite, so bauxite is bauxite is one of the ore of aluminum from which aluminum is aluminum is extracted, and here cryolite is added. Here cryolite is added in order to dissolve the bauxite and to render it conductor of electricity. Since if the uh, bauxite is dissolved, then only it can act as a conductor of electricity. Mm. Since why any object can conduct electricity only only if it has got some free ions in the solution or in the molten state. So it should be in the form of a solution or in the form of a molten state, then only it can act as a conductor of el- electricity. So here cryolite is added to the bauxite in order to dissolve the bauxite, and since then only it will be a conductor of electricity. Will be a conductor of electricity. So option 1 is the correct answer. Then it is told in a galvanic cell, the electrons flow from anode to the cathode in the external circuit. Since why at the anode there is electron lost, so the electrons will move from the anode to the cathode. Since why at the cathode there is gain of electrons and at the anode there is loss of electrons. So in the external circuit, the electrons will move from anode to the cathode in the external circuit. So option 1 is the correct answer. Then the standard electrode potential is measured by voltmeter. So voltmeter is used to measure any kind of voltage or the potential difference. So to measure the standard electrode potential also, voltmeter is used. So option 2 is the correct answer. Then here it is told the corrosion of iron is essentially uh, the corrosion of iron is essentially an electrochemical phenomenon where the cell reaction are. So here, so here the cell reactions which are happening at the anode, at the anode, iron Fe atoms will be oxidized to Fe 2 plus ions, and it will lose 2 electrons. And at the cathode, mm, the oxygen will be reduced in the presence of water. In the presence of H2O, oxygen will be re- reduced. It will gain 4 electrons to form hydroxide ion. So it will happen at the cathode, there is reduction, and at the anode there is oxidation, since there is loss of electrons, and at the cathode there is gain of electrons, so there is reduction. So therefore the overall cell reaction is the overall cell reaction which happens in the case of corrosion of iron, that is Fe plus O2, means 2 Fe will lose 4 electrons, since we have to cancel out the electrons. So 2 Fe plus O2 plus 2 H2O, that gives 2 Fe2 plus 2 Fe, yeah, 2 Fe2 plus 4 OH minus, or I can say it is FeOH whole twice. Here 2 FeOH whole twice will be formed. Means ferrous hydroxide. And then ferrous hydroxide will lose the w- w- water m- molecule uh, to form ferrous hydroxide, or to form ferrous oxide, and um, and Fe2 plus ions can be further oxidized to Fe3 plus ions, means ferric hydroxide, which will lose water to form Fe2O3. And then from here, hydrated ferric oxide will be formed, which is called as the rust. So here it means the iron is oxidized to Fe2 plus, and the dissolved oxygen in water is reduced to hydroxide ion. So option 1 is the correct answer. Then here it is told the hydrogen electrode is dipped in a solution of pH 3 at 25 degrees Celsius. The potential would be, then the potential you have to find. So now, as you know, that hydrogen electrode, for the hydrogen electrode, mm, yep, so for The standard hydrogen electrode, the reaction which happens is 2H plus ion in the aqueous solution will gain 2 electrons to form H2. Now here the E naught cell is 0 since the EMF of the standard hydrogen electrode is 0, or we can say that the reduction potential, the reduction potential of the standard hydrogen electrode is taken as 0 volts. So now therefore, as we know that E cell, that is equals to E naught cell minus 0.059 by n, here 2 electrons are used, so by 2 into log of the pressure of hydrogen by the concentration of H plus whole square. Now here the pressure of hydrogen is equal to 1 atmosphere, so I should use 1 only. Now pH is 3, pH value is told 3, it means that uh, minus log of concentration of H plus, that is equals to 3. It means that the concentration of H plus will be equal to 10 power minus 3. So therefore that is 0 minus 0.059 divided by 2 into log of 1 by 10 power minus 3 whole square, which is 10 power minus 6. So this will come 10 power 6. So therefore the reduction potential, therefore the reduction potential of the hydrogen electrode, that will be equal to minus 0.059 by 2 into log of 1 by 10 power minus 6. So which will go up, which will come 10 power 6. So now log of 10 power 6 will be 6. Log of 10 power 6, that will be obviously 6 only, since log 10 is 1. Since log 10 is equal to 1. So therefore it is minus 0.059 by 2 uh, into 6. So that will be equal to 2 3 is 6. So it will be 3 9s 27, 3 is 15. So 17. So it is minus 0.177 volts. So option 4 is the correct answer. Then it is told which of the following electrolyte will have the maximum flocculation value for ferric hydroxide. So FeOH whole thrice solution. So for having, the rule is that for having maximum flocculation of value, for having maximum flocculation value, hmm, maximum flocculation value, the valency of the coagulation ion should be the least. The valency of the coagulating ion, the valency of the coagulation ion, it means, or the a- anion, or the anion should be the least, should be the least. Since why? The rule is that the flocculation value, that is inversely proportional to Z, means where Z is the valency of valency of the anion, or the valency of the co coagulation ion, valency of the coagulation ion. Now here, as you can see in the first option, the anion is Cl minus, so here the valency is 1. For chloride ion, the valency is 1, and in the second option, we have sulfide ion where the valency is 2, and in the third option we have the phosphate ion, which is the anion, which has valency 3, and in the fourth option we have the sulfate ion whose valency is 2. So it means the least valency is for the chloride ion, So since it has the least valency of the anion, NaCl has least valency of the anion, so it has the highest flocculation value among all these four electrolytes. So option 1 is the correct answer. Then here it is told which one of the following conditions will increase the voltage of the cell represented by this equation. So now here copper solid is reacting with Ag plus aqueous to form Cu2 plus ion and plus 2 Ag solid. So here mm, silver is gaining 2 electrons. So here there is re reduction which will happen at the cathode. The reduction half reaction which will happen at the cathode, and copper is losing 2 electrons, so it is oxidation which is happening. So the oxidation half reaction which is happening at the anode. So, so now here the so now here the QC, which is the reaction quotient, that will be given as the concentration of Cu2 plus divided by the concentration of silver ion whole square. So now therefore the E cell, the EMF of the cell, that is equals to the standard EMF of the cell, E naught cell, minus 0.059 by n. N will be 2 only here, since here 2 electrons are involved. So 2 into log of QC. QC means Cu2 plus ion concentration of Cu2 plus by concentration of silver ion whole square. So now here it means, so now therefore here we can say that in order to increase the voltage of the cell, here the voltage of the cell will increase if this negative part decreases. It means that if the value of the reaction quotient QC decreases. So now if QC has to decrease, then the concentration of the silver ion has to increase, or we should decrease the concentration of Cu2 plus ion. So it means that here we have to either decrease the concentration of Cu2 plus or increase the concentration of Ag plus ions. So if we increase the concentration of Ag plus, then the reaction quotient QC will decrease and the voltage of the cell or the EMF of the cell will increase. So option 4 is the correct answer. Then here it is told when a quantity of electricity is passed through the copper sulfate solution, then here 0.16 gram of copper gets deposited. 0.16 gram of copper gets uh, deposited at the cathode. So if the same quantity of electricity is passed through acidulated water, then the volume of hydrogen that will be liberated at the uh, cathode at STP will be how much? And it is told that the atomic mass of copper is 64. So now here at the cathode, what is happening, that the Cu2 plus ions from copper sulfate, since copper sulfate has got Cu2 plus ions and sulfate ion, SO4 2 minus ions. So the so the Cu2 plus ions will gain 2 electrons to form copper atom. And if acidulated water is used, if acidulated water H2O is used, then what will happen at the cathode? Then at the cathode, the two H plus ions that will gain 2 electrons to form H2 gas. So now, therefore, here the it means here we can see that the weight of copper, or simply we can use the law of the equivalence valence, that the the number of equivalents of copper that will be formed at the cathode, that will be same as the number of equivalents of hydrogen that will be formed at the uh, cathode. So number of equivalents, it means the given weight divided by equivalent weight. Number of equivalents is given as number of equivalents that is equals to the given weight or the given mass divided by equivalent mass or equivalent weight. And equivalent weight that is given as equivalent weight that is equal to the m- molar mass or mo- uh, the molar mass divided by the valency factor. Now here the valency factor for copper, that is 2, and the valency factor for hydrogen, that is also 2. Since in both the cases it is gaining 2 electrons. So now therefore you can say that the equivalent weight of hydrogen, that will be equal to uh, molar mass, which is 2 by 2 gram by 2, which is 1 gram. And similarly the equivalent weight of copper, that will be equal to 64 gram divided by 2, that is equal to 32 gram. Now therefore here it is asked that how much volume of hydrogen that will be uh, liberated. and and also the number of equivalents, that is also given as the number of moles times the valency factor. It means, okay, so it means the number of equivalents of hydrogen that will be formed, that will be equal to the number of moles of hydrogen times 2. Now therefore the number of equivalents of hydrogen, that is 2 into the number of moles of hydrogen, that is equals to the number of equivalents of copper, that will be equal to the given mass which is formed, which is 0.16 gram, divided by the equivalent mass of copper, which is 32 gram. So now therefore the number of moles of hydrogen that is formed, that will be equal to 0.16 by 32 into 2. Now as we know that at STP 1 mole of any gas occupies um, 22,400 centimeter cube. Yeah, it occupies a volume of 22,400 centimeter cube. So therefore the volume of hydrogen that is formed at STP, that will be equal to the number of moles of hydrogen times 22,400 centimeter cube. So it means that will be 16 by 32 into 2 into this is 10 power minus 2 into 2 to 4 into 10 power 2. So 10 power 2, 10 power minus 2 will cancel out. So this much centimeter cube it will be formed. Now 16 2s are 32. So now 4 5s are 20, 4 6 are 24. So 56 centimeter cube of volume of hydrogen will be liberated at STP at the cathode. So option 2 is the correct answer. Then it is told which of the following does not conduct electricity. So now for so as we know that for conduction of electricity, any substance should be kept, any substance should uh, contain, any substance should contain free ions, should contain free ions which can move, which can move in the solution or in the molten state. So it means the substance should be either kept in the solution form or in the m- molten state. So it means the substance should be either in the molten state, or I can say it is the fused state, or in the solution state, or in the aqueous solution state, aqueous solution state. Since why in the aqueous solution it can form uh, uh, ions like NaCl. If it is in the solution state, then it will form Na plus ions in the aqueous solution and Cl minus ions in the aqueous solutions, which can easily flow in the solution and it can conduct e- electricity. And also if it is in the molten state or in the fused state, then also it can conduct electricity. So, and brine solution, it means that the aqueous solution of NaCl, and copper also, it can conduct e- e- electricity since it is a pure uh, conductor. So if it is in the solid state, then also it can conduct if it has got free electrons in it. So since copper is a metal, since copper it is a metal, so it has got free electrons in it which can flow easily through it when some potential difference or voltage is created across it. So if some voltage or potential difference is created across it, then the free electrons can flow through it and one electric current will be formed in the opposite direction of the flow of the electrons. So here, mm, so it means that solid NaCl will not contain any free ions. Since why here in solid form of NaCl, uh, it will form a crystalline lattice will be formed here, and which will have alternate Na plus ions and Cl minus ions, which are arranged in the solid state, in the solid lattice, so which can't move freely. So hence solid NaCl will not conduct electricity. So hence option 2 is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter electrochemistry. So still any doubts if you have, then please write that in the comments section. Um, we, we shall obviously clarify them in the subsequent videos. And also please install our Sapience Education application, where we shall upload some more important questions based on the previous year KCET exam on every chapter of chemistry. So thank you everyone. Bye.